The night sky. We've all looked up at it and wondered, what's out there? Where does it end? When did it begin? We could spend forever wondering. Or we could set out to see the universe for ourselves and travel as far as we can go. To feel the fierce heat of burning stars. Face the force of violent cosmic collisions. Dodge Death Stars and insatiable supermassive black holes. Witness the birth of new stars and reach the limits of human understanding. We must go on a journey back in time to the beginnings of the universe to see for ourselves the moment it all began, the Big Bang. Are you ready? Then let's go on a journey to the edge of the universe. This is the beginning of space. Only 100 kilometers up, just an hour's drive from home. Down there, life continues. The traffic keeps moving. Stock markets go on trading, and the same old reality shows are still running.
The Blue Jays will be without starter Jim Clancy for a couple of weeks. He's having problems this morning.
Order! Would the honourable gentleman resume his seat? Mr. Ashdown.
But we have to leave all this behind. And set out for the edge of the universe. First stop, the moon. "27 American astronauts have come this way before us. 12 of them have walked on the moon itself. When the Apollo astronauts radioed home, their messages took over a second to reach Earth. Even though the messages traveled at the speed of light, 300,000 kilometers per second. So Mission Control heard events after they'd happened. If there's a second's difference between Earth and our nearest neighbor, imagine the difference if we make it to the edge of the universe. We'd be going back not a few seconds, but billions of years. Less than 400,000 kilometers from Earth, 3 days in a spacecraft. It looks like a deserted battlefield, bombarded by millions of meteoroids and asteroids. But it's quieter now. It's obvious there have been no major collisions for millions of years. The Apollo 11 lunar module.
The Eagle has landed. It's one small step for man, one giant leap for mankind.
For the Apollo astronauts, the risks were high.
Hey, Ron is finally here, Houston. Beautiful, beautiful. Isn't that something?
But the rewards were higher. To see our planet as it had never been seen. To step where no human had stepped before. And to visit another world. A world blasted by the sun's deadly radiation. It's just endless congealed lava, piles of dull, grey rocks.
Go ahead. Oh, that view is tremendous. Go for it.
The Apollo astronauts took hundreds of them home for scientists to analyze. And it turns out these dull grey rocks aren't so dull after all. NASA's scientists discovered the rocks had been superheated, evidence of a massive impact. 4.5 billion years ago, a stray planet smashed into Earth. It blasted billions of tons of molten rock out into space, and this came together to make the Moon. Until this discovery, we thought the Moon was unrelated to Earth, a space rock controlled by the Earth's powerful gravitational pull. Now we know it's made from the same material as our own planet, that the Moon came from the Earth.
They're setting up the flag now. Beautiful, just beautiful.
Neil Armstrong's first footprints. They look like they were made yesterday. And with no wind here to blow them away, they should survive for millions of years. It's time to take our own giant leap. Further than any human has ever traveled. Out of the darkness, the goddess of love, Venus. The morning star, the evening star. Venus is the solar system's brightest planet. Its spectacular yellow clouds reflect the sunlight. A sister to our planet. She's about the same size and gravity as Earth. But the Venus Express space probe is telling us these dazzling clouds are made of deadly sulfuric acid, that the planet's atmosphere is choked with carbon dioxide. Venus is an angry goddess. The air is noxious, the pressure unbearable, and it's hot, approaching 500 degrees Celsius. Stay too long, and we'd be corroded, suffocated, crushed, and baked. Nothing can survive here. Like this. It's a Soviet Venera robotic probe. Its heavy armor's being wrecked by the extreme atmosphere. So lovely from Earth. Up close, Venus is the sister from hell, pockmarked by thousands of volcanoes. All that carbon dioxide in its atmosphere is trapping the sun's heat. This is global warming gone wild. Before it took hold, maybe Venus was calm, more like her sister planet Earth. If that's true, this could be our planet's future. A future shaped by the sun. But before we can reach it, there's this. Mercury, the smallest planet in the solar system. Get too close to the sun, this is what happens. Temperatures swing wildly here. At night, it's minus 170 degrees. Come midday, it's 400 plus. Burnt, frozen, and covered in scars. It seems Mercury had a violent past. The Messenger space probe is telling us something strange. For its size, this little planet has a powerful gravitational pull. It must be heavier than it looks. It's like a huge ball of iron, covered with a thin veneer of rock, the core of what was once a much larger planet. So where's the rest of it? Maybe a stray planet slammed into Mercury, blasting away its outer layers, to leave a planet that's almost entirely metal. The sun, in all its mesmerizing splendor. Everything we do is controlled by the sun. All our lives depend on it. Throughout history, across cultures, it's the pivot around which life on Earth revolves, nurturing our crops, structuring our days, inspiring our beliefs. A 150 million kilometers from home, a 20-year journey by plane. Switch it off, and it's so far away, we wouldn't know about it for a whole 8 minutes. It's so big, you could fit 1 million Earths inside it. So heavy, its gravity controls the entire solar system. We see it every day, a familiar face in our sky. Up close, it's unrecognizable. A turbulent sea of incandescent gas. The thermometer rises to over 5,000 degrees. Down in the core, it's got to be tens of millions of degrees. Hot enough to trigger a nuclear reaction, turning millions of tons of matter into energy every second. More than all the energy ever made by mankind. Back home, we see this energy as light and feel it as heat. But up close, there's nothing comforting about the sun. It's so full of electrical and magnetic activity, it's bursting out in these huge incandescent gas loops called prominences. Each one releasing more energy than 10 million volcanoes. You could get the Earth through one of these loops and still have tens of thousands of kilometers to spare. And where they burst through, it's exposing the cooler layers below, making sunspots. They're a fraction cooler than their surroundings. It's why they look black, but they're still hotter than anything on Earth. And they're massive too. Some of these are at least 50,000 kilometers across, wide enough to swallow the entire Earth. A solar flare. A superheated stream of electrified gas blasting deadly radiation out into space. But one day, the sun's fuel will be spent. It will die. When it does, so will life on Earth. The sun creates life and destroys it. Demands we keep our distance. This comet has strayed too close. It's being boiled away by the sun's heat, creating a tail that stretches for millions of kilometers. It's freezing in here. There's no doubt where this comet's come from. The icy wastes of deep space. Steam, geysers, and dust. It's the sun again, melting the comet's frozen heart. It's a kind of vast, dirty snowball, covered in grimy tar. Tiny grains of what looks like organic material, preserved on ice since, well, who knows when. Maybe even the beginning of the solar system. If a comet like this crashed into the young Earth billions of years ago, it could have delivered organic material and water, the raw ingredients of life. It may have even sown the seeds of life on Earth that evolved into you and me. But what if it crashed into Earth now? You only have to think of the dinosaurs, wiped out by a comet or an asteroid strike 65 million years ago, to realize it wouldn't be good news. It's just a question of time. Eventually, one day, unless we can find a way to protect ourselves, we'll face the same fate as the dinosaurs. The Earth is safe, for now. But if life on Earth was threatened, we'd need to escape and find another home. Among the millions, billions of planets, there must be one that's not too hot, not too cold, with air, sunlight, water. The red planet. Unmistakably, Mars. For centuries, we've looked to Mars for company, for signs of life. It sounds like science fiction, but today astronomers think Mars could be our best chance of finding alien life. They're watching the planet, scanning it, probing it. More than any other planet, Mars captures our imagination. Think of sci-fi films, comics, and you think of Martians. It's all just fiction, right? But what if there really is something here? If there is, it's living on a dead planet. The processes that make Earth habitable shut down hundreds of millions of years ago here. Red and dead, Mars is a giant fossil. But there's wind here. A dust devil, a big one. Bigger than the biggest tornadoes back on Earth. And where there's wind, there's air. that could sustain extraterrestrial life. But it's too thin for us to breathe, full of choking carbon dioxide. There's nothing to protect Mars from the sun's ultraviolet rays. And it's cold, as low as -80 degrees, freezing water in the ground, at the poles, and even in the atmosphere, as snow. It's hard to believe anything could live here. Back on Earth, there are creatures that survive in extreme cold, heat, even in the deepest, darkest ocean trenches. Even in the most extreme conditions, life usually finds a way. But here on Mars, with no geological activity to replenish the minerals and nutrients in its soil, no heat to melt its frozen water, and all this dust, it's hard to see where we're going. But the surface of Mars is dotted with remarkable features. So huge, they're impossible to miss. Olympus Mons, a vast ancient volcano, 3 times higher than Everest. There's no sign of activity. Since its discovery in the 1970s, it's been declared extinct. Any lava flows should be long dead, obliterated by meteorite impacts. Unless this monster isn't dead after all. If it's not, there could be molten magma beneath the crust right now. Volcanic activity could be melting frozen water in the soil, where life could still survive. This makes the Grand Canyon look like a crack in the pavement. It goes on and on. So far, it would stretch all the way across North America. And there are signs of erosion of dried up riverbeds, as though volcanic activity melted ice in the soil, sending water flowing through this canyon. And if there's water running on Mars right now, then there's a chance we could find life here. So the hunt is on. Trundling across this desolate landscape, the NASA rover Opportunity. It's finding evidence that these barren plains were once ancient lakes or oceans that could have harbored life. And look at these. When probes orbiting Mars pass over these gullies, they keep spotting new ones. More proof that Mars may be alive and kicking. That there could be water flowing beneath its surface, creating these gullies. Water which could sustain Martian life. Now all we have to do is find it. But we might already have found it, because incredibly, Mars may be the place where life on Earth originated. It sounds crazy, but there's a theory that life started here before moving to Earth. The idea is that an asteroid impact blasted fragments of Mars, complete with tiny microbes, out into space and onto the young Earth, where they sowed the seeds of life itself. No wonder we find Mars fascinating. It could be our ancestral home. If it's true, it means we're all Martians. We thought this was a dead planet, but it may be more alive than we ever imagined. Mars, possibly the solar system's most studied planet, continues to confound us. So what other surprises are out there, waiting to be discovered? This is like being inside a giant computer game. Asteroids, some of them hundreds of kilometers wide. This one must be about 30 kilometers long. And look. It can't have been easy parking a probe on an asteroid traveling at 80,000 kilometers an hour. It's a lot of effort to investigate a lump of rock. Rocks that collide, break up, and rain down on Earth as meteorites. It was rocks like these that came together to make the planets, including our own. So by dating the meteorites we find on Earth, we know the planets were born 4.5 billion years ago. These are the birth certificates of our solar system. But for some reason, these rocks didn't form into a planet. Something must have stopped them. Something powerful. Jupiter. What a monster. At least 1,000 times bigger than Earth. So vast, you could fit all the other planets inside it. Something this big is going to have a major effect on its neighbors. Its gravity is stopping the asteroids from forming a planet. But this huge planet is almost all gas. Land here and we'd sink through its layers, probably never hitting a solid surface. And Jupiter's good looks, the product of extreme violence. It's spinning at a huge rate, whipping up winds to hundreds of kilometers an hour, contorting the clouds into stripes, eddies, whirlpools. And this, the legendary Great Red Spot. The biggest, most violent storm in the solar system. At least 3 times the size of Earth, it's been raging for over 300 years. All those churning clouds have sparked an electrical storm. Just one bolt is 10,000 times more intense than any at home. It seems the best place, the safest place to see Jupiter is from a distance. Look at those lights. They're like the aurora back home, dancing around the poles. But even these are deadly. They're generated by lethal radiation pulled from space by Jupiter's powerful magnetic field. Alluring from a distance, terrifying up close. Out here, nothing is what it seems. The universe is full of contradictions. We have to proceed with caution, weaving through the paths of Jupiter's 62 or more moons. This multicolored moon is called Io. But like Jupiter, its beauty is only skin deep. Those pretty colors are molten rock, sulfur, volcanoes spewing burning hot ash and sulfur hundreds of kilometers into the air. Jupiter's mighty gravitational pull is twisting and stretching Io, creating enough friction to melt this moon inside. On our journey to the edge of the universe, we found no life, nowhere we could call home, so far. But there's always another planet, moon, another world of possibilities just over the horizon. Like this, it's Europa, another of Jupiter's moons. 650 million kilometers from home. What a weird-looking place. And yet it seems strangely familiar. It's a bit like the Arctic, with all that ice, all those ridges and cracks. And maybe, like the Arctic, this ice is floating on water. Liquid water. It's a fascinating possibility. But we're 800 million kilometers from the sun. Europa should be frozen solid. Unless Jupiter's gravity is creating friction deep inside, stopping Europa from freezing, allowing life to develop in the waters beneath its frozen crust. We might be meters away from aliens, from a whole ecosystem of microbes, crustaceans, maybe even squid. The only thing between us and the possibility of alien life, this layer of ice. But until we send a spacecraft to drill through the ice, Europa will remain one of the solar system's greatest mysteries. It's captivated our imaginations, haunted our dreams. And here it is, spinning before our eyes. Saturn, the jewel in the solar system's crown. There's something magical about Saturn. A giant ball of gas, so light it would float on water. Its spectacular rings would stretch almost from Earth to the moon. But they're just a few hundred meters deep. The Cassini orbiter. It's picking up ghostly radio emissions, probably generated by auroras around Saturn's poles. This is the real music of the spheres. And it's telling us these rings are most likely all that's left of a moon shattered by Saturn's gravitational pull. Incomparable beauty from total destruction. Billions of shards of ice, some as small as ice cubes, others the size of houses. They collide, break apart, reassemble. It's like a snapshot of our early solar system. A as dust and gas orbited the newly born sun. And gravity worked its magic, pulling the lumps together. Until from debris like this, our planet emerged. Every single object orbiting Saturn is technically a moon, from the smallest shard of ice to this. A moon larger than our own, Titan. It's shrouded by thick orange clouds. But beneath them, it seems like there's an atmosphere down here. There's wind, rain, even seasons. And rivers, lakes, and oceans. It's the most similar place to Earth we've seen so far. Except that's not water. That's liquid natural gas. There must be hundreds of times more natural gas here than all the Earth's oil and gas reserves. If we could get it home, it could power our cities, fuel our cars for thousands of years. Or maybe, one day, we could use it here to fuel a colony, assuming there isn't life on Titan already. The Huygens space probe, dropped onto Titan's surface from Cassini, is here to find out. It's telling us there are organic materials in the soil, but it's so cold, minus 180 degrees. There's no way these could come together to form life. Unless Titan warms up. The sun is predicted to get hotter. When it does, maybe life will spring up here, just like it did on Earth billions of years ago. As the Earth gets too hot for us, maybe we'll move to Titan. One day we might call this distant moon home. Home. We're at least 1 billion kilometers away now. Beyond this point, we lose visual contact with the Earth. And whatever's out there is invisible from Earth with the naked eye. We're heading into the solar system's mysterious outer reaches, territory that for most of history, nobody knew existed. It's like diving down into the deep ocean. Uranus. Its strange rings were only discovered in 1977. They make this giant planet look as though it's been tilted off its axis, toppled over in an ancient collision, perhaps with a stray planet. It feels a long way from home. But the truth is, we've barely left the shore. We're over 2 billion kilometers from Earth, but to reach the edge of the solar system, we've got to travel 10,000 times further. Out of the inky blackness, another strange beast, the god of the sea, Neptune. It looks serene, but that spot is a storm the size of Earth. whipped up by savage 1,500 km/h winds. Back on Earth, it's the sun that drives the wind. But Neptune's too far away. Something else must be creating these ferocious winds. But nobody knows what. Plunging further into the solar system's outer reaches. Orbiting the gas giant, a solid moon, Triton. It's solid, but far from stable. It's covered in geysers, cosmic chimneys pumping out strange soot. And it's orbiting Neptune in the opposite direction to the planet's spin. A cosmic battle of wills that this angry moon is always going to lose. It's being slowed down, reeled in by Neptune's massive gravity. One day Triton will be ripped apart. We've seen every planet in our solar system. But beyond the planets, it's not empty. It's teeming with frozen rocks, icy spheres. Like Pluto. Until recently, it seemed Pluto was alone, that there was nothing else out here. We were wrong. More frozen worlds. Discoveries so new, nobody can agree what to call them. Plutinos, ice dwarfs, cubanos. It seems our solar system isn't the neat model we thought it was. It's littered with debris and rubble left over from its creation. Over 13 billion kilometers from home. The most distant thing ever seen to orbit the sun. Another small, icy world called Sedna, discovered in 2003. Its orbit takes 10,000 years and sends it 130 billion kilometers from the sun. There's something else out here. 16 billion kilometers from home, the space probe Voyager 1. If it wasn't for this, we'd have no images of the giant planets, no clue about their strange moons. It's traveling 20 times faster than a bullet, sending messages home. That gold panel, it's a kind of intergalactic message in a bottle. There's a greeting recorded in 55 different languages.
Hello from the children of planet Earth.
Hola y saludos a todos.
And a map showing how to find our solar system. But do we really want to advertise our existence? Anyone, anything could hear our call, find out where we live, and come knocking. Friend or foe. Next, a cloud of cosmic icebergs. Frozen blocks of water, dust, and gas, like the comet we saw earlier. It was comets that may have planted the seeds of life on Earth billions of years ago. And if they came from out here, seeing all this ice, perhaps they carried water to Earth too. The water in the oceans, in your coffee, even in your body, all from this distant celestial ice machine. We're 8 million. That's 8 trillion kilometers from home. On the very edge of our solar system. On the brink of going where no human, no probe has gone before. Welcome to interstellar space, far beyond our solar system. Billions of stars like our own sun, many with planets, many of those with moons. Infinite possibilities in every direction. Whichever way, we're going to need a serious burst of acceleration. Trillion kilometers from home. 150,000-year ride in the space shuttle. And we've only just reached the first solar system after our own. Alpha Centauri. 1 star and 2 more. They're spinning around each other, locked in a celestial standoff. Each star's gravity attracting the other, their insane orbital speed keeping them apart. We're so far from home now, the kilometers are becoming meaningless. We're going to have to talk in light years. A beam of light takes 1 year to travel 10 trillion kilometers. So 40 trillion kilometers is over 4 light years from home. It's mind-boggling. Distances so vast they're almost beyond comprehension. And exciting. Who knows what strange worlds lie ahead? Light years from Earth, the star Epsilon Eridani. Spectacular rings of dust and ice, and somewhere in there, planets forming out of the debris, being born before our eyes. Asteroids and comets everywhere. We could almost be looking at our own solar system, billions of years ago, with comets delivering organic molecules, water to these young planets, kick-starting life, just as they may have done on Earth. At the center of all the action, a star smaller than our own sun. It's still in its infancy. Any life in this solar system would be primitive at best. There must be more mature, developed solar systems out here. But finding them is like looking for a needle in a cosmic haystack. We're now 20 light years from Earth. Star Gliese 581. It's about the same age as our sun. And orbiting it, this planet. It's just the right distance from its sun. Any closer and water would boil away. Any further, and it would freeze. Ideal conditions for life to have evolved. And if comets have struck, delivering water and organic materials, then life, complex beings like us, even civilizations like our own, could be down there, right now. If there are, even at this distance, they could be tuning into our TV signals, watching shows broadcast from Earth over 20 years ago.
And here's your host, Joe Jackman.
But until future generations can find a way of communicating over these vast distances, all we can do is speculate. In fact, life may have already prospered here, only to have been annihilated. That's the problem with comets. They're creators and destroyers, as the dinosaurs found out the hard way. This is the needle in the cosmic haystack, the closest we've come to a habitable solar system like our own. But it's a chance encounter. There could be hundreds, millions more solar systems like this out here, or none at all. This is vast. And look, some of its atmosphere is being boiled away by its nearby star. It's the planet Bellerophon. The first planet to be discovered outside our solar system in 1995. The problem is, from Earth it's hard to spot, obscured by the brilliance of its neighboring star. But it has a minute gravitational pull on its parent star. Measure these tiny movements trillions of kilometers away, and we can prove this planet exists. That's how we tracked down Bellerophon and opened the floodgates to the discovery of hundreds of other distant planets. The further we go, the further back in time we travel. We're 65 light years from Earth. Tune in on this bright star, and you'd pick up TV signals from Hitler's Berlin Olympics in 1936. Twin stars. It's Algol, the demon star, feared since ancient times. From Earth, it appears as one star that flashes on and off. But up close, we can see in reality, it's two stars. And one is being sucked towards the other. Almost 100 light years from home. Listen. One of the first ever radio broadcasts. Just a faint whisper.
We'd appreciate it if anyone hearing this broadcast would communicate with us. We are very anxious to know how far the broadcast is reaching.
And then silence. From here on out, it's as if Earth never existed. Any aliens living beyond here will have no idea we're there. And the further we travel, the less familiar, more dangerous our universe will become. Deep inside our galaxy, the Milky Way, a vast celestial library. Each star a book with a story to tell. The Seven Sisters, transformed into stars in ancient Greek myth. And this giant, Betelgeuse. The brightest, biggest star we've seen so far, at least 600 times wider than our sun. But this, it's not a star. Not a planet. Not like anything we've ever seen. A ghostly spectre, more than 1,300 light years from Earth. Orion's dark cloud. Dust and gas, so dense it's blocking out the universe beyond. And deep inside, a ball of light, pulling the dust and gas towards it, heating up, merging into a ball of burning hot gas, like a star, like our sun, in miniature. Inside, temperatures reach millions of degrees. So hot, it's beginning to trigger nuclear reactions, the kind that keep our sun shining. Making energy, radiation, light. A star is being born. Or rather, stars. Orion's dark cloud is a vast star factory. We came here expecting horrors. Instead, we've discovered one of the universe's greatest wonders, star birth. We're witnessing the birth of the future universe. Jets of gas, exploding outwards at 200,000 kilometers an hour. Blasting dust and gas out for millions of kilometers. It's unbelievably violent. But look at the results. Nebula. Vast, glowing clouds of gas hanging in space. With no wind out here, they'll take thousands of years to disperse. This nebula is so vast it would take 250,000 years just to travel around it in a spacecraft. But its immense size is overshadowed by its strange shape. It looks like a giant horse's head, rearing up in space. Stars are born, grow up, and then what? Do they die? Do they slip quietly into the night, or go out with a bang? Whatever happens next will happen to our own sun. Its fate lies out here, somewhere. nearly 4,000 light-years further. Luminous clouds suspended in space, encircling what was once a star like our sun. All that's left of it are these brightly colored gases. Elements formed by nuclear fusion deep inside the star, released into space on its death. Green and violet, hydrogen and helium, the raw materials of the universe. Red and blue, nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. The oxygen in our lungs, the nitrogen in our DNA. It was all produced by nuclear fusion in stars that died long before the Earth was even born. We are made of stellar nuclear waste. At its heart, the ghost of a star. It's a white dwarf. White and incredibly hot. Small, but unbelievably dense. In the star's dying moments, its atoms fused and squeezed together, making it so dense that just a teaspoon of this white dwarf would weigh 1 ton. It's a chilling premonition of our sun's fate. 6 billion years from now, it'll become a white dwarf. Its death will herald the end of life on Earth. It makes you wonder how many other worlds have been and gone. Stories left untold. Celestial books lost forever. But the greatest story of them all is still to be told. We must go back through time to the very first chapter to tell the story of how the universe began. These are the scattered remains of a dead star. A nebula, the Crab Nebula. We're 6,000 light years from home, deep inside a stellar graveyard. Dust and gas, stretching for trillions of kilometers. It looks dead. But maybe this is just the calm after the storm. After a massive explosion, powerful enough to turn a huge star into a cloud of dust and gas, a supernova. The eye of the storm, a spinning, pulsating star, a pulsar. Gravity has squeezed the giant star's core down to this. It's just 20 kilometers across, making it unimaginably dense. One pinhead of this would weigh hundreds, maybe millions of tons. As it shrank, like a figure skater spinning on the spot, arms outstretched, then pulling them in, it began to spin faster. 2 beams of light, energy, radiation, spinning 30 times a second, powering the huge cloud of dust and gas. There's so much radiation here, more even than on the sun. If this pulsar got as close to Earth as our sun, our planet would be instantly stripped of life. That was easily the deadliest thing we've encountered so far. Until now. It's the one thing we didn't want to encounter. Impossibly black, blotting out the stars behind it. We're staring into the face of death. The remains of a giant star. A black hole. Instead of contracting to a white dwarf or a pulsar, it just kept on going. Shrinking until it got so small, it's just a few kilometers across. Far denser than a pulsar and impossible to resist. Stray too close, and there's no turning back. Now we know why it's a black hole. Its gravity is so intense, not even light can escape. This asteroid, a lump of solid rock, is stretching, being dragged towards the gaping hole. Inside, there's no matter as we know it. No time, no space. All the rules of physics collapse. The asteroid is gone. Truth is, nobody really knows where. We're looking at the limit of scientific knowledge. There could be millions of black holes creeping around our galaxy. More perhaps than all the stars in the sky. But we wouldn't see them until it was too late. Like this star, spiraling down an invisible plug hole. Who's to say we don't live inside a vast black hole? That the whole universe isn't inside one right now, inside another universe. Sometimes it feels like the more we see, the less we know. But we do know our galaxy is more complex and more dangerous than we ever imagined. And we're only in our own galaxy, the Milky Way. The rest of the universe still lies ahead. The wonders, the dangers, the secrets, they're out there. But first, we've got to find a way out of the Milky Way. We're now 7,000 light years from home, deep inside our own galaxy. Traveling towards the edge of the universe. We still have to journey many millions of light years. But there's plenty to see on the way. A colossal glowing cloud topped by these great towers of dust. The pillars of creation. Like a gateway into the far galaxy. Both pillars are studded with tiny bulges, embryonic star systems, each one the size of our solar system. It's another monument to nature's astonishing creativity. But not a permanent one. Radiation from hot stars nearby is destroying it. In just a few million years, this immense nebula will be gone. The blink of an eye in astronomical terms. Dazzled by the Milky Way's beauty, we've strayed into a cosmic minefield. Giant clouds of gas bursting out of this star. A star millions of times brighter than our sun. The nuclear reactions that power it are winding down. We're watching its death throes. Eventually, the core will implode. The result, a new black hole. An even bigger, even more dangerously unstable star. But this one's about to explode. And when a star this big dies, it's 100 times more violent than a supernova. Somehow we've stumbled into the most violent star death imaginable. A hypernova. The core's collapsed. It's becoming a black hole. And that's the shockwave, surging through the star, ripping its outer layers into space. There's lethal radiation everywhere, enough to have a catastrophic effect on any planet unlucky enough to be nearby. When virtually every species on Earth was wiped out 450 million years ago, the culprit may have been one of these. Deadly hypernovas, frozen comets, scorched planets, white dwarfs, red giants, Earth. Tiny drops in a vast pool of white light. Our home galaxy, the Milky Way. We wanted to know where we fit in. Here's our answer. Civilizations, past and present. Everyone that's ever lived. The smallest bug, the highest mountain. All of it. Invisible. Not even a tiny speck. Our home is a minor planet of an insignificant star. If it disappeared right now, we wouldn't even notice. And yet, so far we've found nowhere else we would rather live. Nowhere we could live. But look at all these stars. Hundreds of thousands of them. Surely one of these, more than one, must be capable of supporting life. be here in this swarm of stars, the Great Cluster. Back in the 1970s, astronomers sent a message in this direction, detailing the structure of our DNA and showing a plan of our solar system. But it's so far from home, the message won't arrive for at least another 25,000 years. We haven't found alien life yet, but neither have we found any reason to believe it isn't out here, somewhere. There's an equation devised to estimate the number of other advanced civilizations. And the results are shocking. There could be millions of civilizations just in our galaxy. Everything we have seen so far is inside the Milky Way. Now here's our chance to see other galaxies, to glimpse the even bigger picture, and perhaps to answer the ultimate question: where does all this come from? It's time to leave our solar system, our galaxy. To travel beyond the Milky Way, through the vast expanse between galaxies, and into intergalactic space. Out here, there's no horizon in sight. Even the closest galaxies are hundreds of thousands of light years away. The remains of galaxies ripped apart by the Milky Way's huge gravitational pull. Scattered through nothing. This is as close as the universe gets to a perfect vacuum. But even this isn't totally empty. There are thin wisps of gas, fine traces of dust, and something else. Dark matter. So mysterious, we can't see it, feel it, touch it, or even measure it. Yet so common, it could make up over 90% of all the matter in the universe. If dark matter does exist, it means there's no such thing as empty space. Even out here, we're surrounded by matter. We only suspect it exists because of the strange hold it seems to exert on galaxies. Like this one, the Large Magellanic Cloud. More than 6 billion years in today's fastest spacecraft, 160,000 light-years from the Milky Way, at the edge of its gravitational reach. This galaxy should spin off into space, but something seems to be holding it here. Something invisible, powerful, dark matter. Stars, clusters of stars, nebulae. It's a vast astronomical treasure house. A fireball, expanding out from what must have been a massive explosion, a supernova. So bright that when light from the explosion reached Earth in 1987, it was visible with the naked eye. And so violent, it triggered a string of nuclear reactions, forcing atoms together, creating new elements: gold, silver, platinum, blasting them out into space. gold in the ring on your finger was forged in a massive supernova like this, trillions of kilometers away, billions of years ago. It's an astonishing thought. The stars, which seem so remote from Earth, directly affect our lives. It's comforting to remember as we venture further through the abyss. The Andromeda Galaxy, 2.5 million light-years away. It's moving through space at nearly 1 million kilometers an hour. Everything in space is moving apart like shrapnel from an explosion. We're seeing this galaxy as it was when our ape-like ancestors first walked across the African plains. We go further through space and further back in time to find a whole galaxy exploding. The only thing large enough to cause an explosion on this scale has to be a collision with another galaxy. But this galaxy won't die. It'll be reborn. A new shape, perhaps even new stars, as dust and gas collide, creating friction, shockwaves, triggering the birth of yet more stars. There's order in this chaos, a pattern behind the infinite variety, an endless cycle of birth and death, creation and destruction. It's a pattern woven through the vast fabric of space that binds each of these galaxies. There are billions of galaxies in the universe, each with billions, even trillions of stars. Possibly more stars than there are grains of sand on all the beaches on Earth. And all of these are just the stars that exist now. What about the stars that have been and gone? All the stars being born, yet to be born. We're finally beginning to see the big picture, and it's bigger than we ever imagined. This galaxy, the huge Pinwheel Galaxy, is so far from Earth that if we send a message home now, it will take 27 million years to get there. Who knows whether our species, our planet, will still be around to receive it. We travel on, back through time. Past the point where the dinosaurs were wiped out. Past the moment where the first creatures clambered onto land. "2 billion light years from home, closing in on the edge of the universe, going back to the beginning of time." This isn't a galaxy. It's brighter than hundreds of galaxies put together. A blinding beam of energy bursting out for trillions of kilometers. Something this big, this bright, must be incredibly powerful. Experience tells us out here, power equals danger. It's a quasar, the deadliest, most powerful thing in the universe. A swirling cauldron of super-hot gas. Brighter than hundreds of galaxies. The source of this awesome power lies deep inside the heart of the beast. A heart of darkness. A supermassive black hole as heavy as 1 billion suns. It's ripping apart whole stars, sucking their gases into the quasar, devouring them, until they're nothing, lost forever from the visible universe. We've seen the worst the universe can throw at us. Its most powerful destructive forces. Now our path is clear. The very edge of the universe is almost within reach. But we still need to go further, faster, if we're to cross the final reaches of the universe. $8 billion light years from home. More galaxies. But these look different. Ragged, small, close together. We're so far back in time, we're seeing these galaxies as they were before the Earth was even born. They're still young, still growing. We're getting closer to where and how it all began. 12 billion years ago. Look at the galaxies now. They're more like primitive plankton floating in a vast, dark ocean. It's magical. Clouds of dust and gas, dancing, forming a shape, merging to make embryonic galaxies. This is how our own galaxy was born. But now, they're disappearing. We've gone back before the stars were born, into a cosmic dark age. And before that, light. The afterglow from a massive explosion. The explosion which created the universe. We're almost there. This is it. We've made it. The edge of the universe. 130 billion trillion kilometers from home. 13.5 billion years ago. The very instant of the Big Bang. The most violent, most creative moment in history. Everything that's ever happened was triggered in this moment. Every religion, every culture has pondered it. But we still don't know what sparked this act of creation, or why. This is where our journey ends, and the universe begins. An infinitely hot, small, dense point erupts. Creating space, time, matter, our universe itself. First, it's the size of a subatomic particle. The tiniest fraction of a second later, it's big enough to hold in the palm of your hand. Moments later, it's the size of the Earth. Today, the light from the Big Bang is still spreading out as a hiss of radio static. Your TV aerial picks it up. You can see it as static on an untuned TV. We go on, forwards through time. All the things we've seen on our journey are sparks flying out from the Big Bang. Galaxies, stars, planets, all just debris. Back through our galaxy. Our solar system. Until we reach another cooling cinder swirling in the afterglow of the Big Bang. The Earth, our home. But the story doesn't end here. The effects of the Big Bang are still unfolding. The universe still changing. "3 billion years from now, the vast Andromeda galaxy will smash into our own, creating a new galaxy. The sun and planets will survive, but they'll be thrown into a huge looping orbit around the new galaxy. The sun will become a red giant, swallowing up Mercury and Venus, scorching our planet's surface, destroying all life on Earth. Then it will die, shrinking to a white dwarf. Neighboring stars will die too, to be replaced by white dwarfs, pulsars, black holes. The lights will go down on the galaxy. Since the Big Bang, the universe has been fading, dying. Not with a bang, but with a long, drawn-out whimper. But there could be a way out, an escape route from our dying universe. It might be possible for our distant descendants to find a shortcut through space and time, a wormhole. If there are other universes, it could take our descendants from our doomed universe into a parallel one, where they could find another Earth, still in the prime of life. If they're lucky enough, they will live on in a new universe, a new planet, a new home.